You found the video for the third day of exponentials and logs. Today we're going to do two things. We're going to look at finding inverses graphically. We're going to convert back and forth between exponential and logarithmic forms. We're also going to evaluate logarithmic expressions. So our first learning target is finding the inverse of an exponential and logarithmic function graphically. Since they're inverses of each other, we're going to take some points and switch the x and y values. Find the inverse of a function graphically. Find some points on the graph and switch the x and y coordinates. So here is the point -1, 2. Switch the x and y value. We want to plot the point to -1. To -1 will be a point on our inverse graph. If we take the point -2, 0, switch that. We're going to plot the point 0, -2. And there's 3 here, so I'm going to switch all 3. -3 and -2/3, I'm going to switch that and do -2/3, not quite -1, and -3. So my inverse graph is going to go through these 3 new points that I plotted. We can see here the asymptote on this exponential function is y equals -1. If we switch the x and the y for the points, we're also going to switch the x and the y for the asymptote. So this y equals -1, we're going to change that into an x. So x equals -1. That's going to be our asymptote for our inverse function. A little crooked there. So if we graph our log, just run right along that exponent, or sorry, that asymptote, and curve through the 3 points that you plotted. And we have graphed the inverse. So we knew how to set up tables and switch them and then go ahead and plot the points. But if you're given the graph, just pick out some points that are on the graph and switch them. So the next one I know you'll be able to do just fine. We have the point 7, 3. We'll switch that and we'll graph the point 3, 7. Now it's okay that this point's on this vertical asymptote because I'm going to end up switching the asymptote. That's not where it's going to end up. Switch this point, we'll have 2, 4, and the third one. So switch it and I'll have 1.5 and 3.5. The vertical asymptote that is here is the equation x equals 3. I'm going to change that x to a y, so my horizontal asymptote will be y equals 3. So if I put that in first, it will help me shape my graph nicely. So I'm going to run right along that asymptote and then curve up through the 3 points that I plotted. And do these graphs look like reflections over the diagonal line y equals x? I just want to graph that. Okay, well, we want to look like a reflection over this diagonal line y equals x. So if I folded either graph along this line y equals x, would one graph stamp onto the other? The answer should be yes. And we have graphed the inverse. And we've done it graphically because we started with a graph and we switched some points. Our next learning target is learning target L. I can convert an expression in exponential form to logarithmic form and vice versa. So we look at the definition of a logarithm with base b. We're going to let b and y be positive numbers, and b is not going to be 1. We read this log base b of y equals x. So how we read it there. Log base b of y equals x is the same thing as b to the x power equals y. So this means the same thing. Just 2 ways to write it. So we can convert back and forth between the logarithmic expression we see on the left and the exponential expression we see on the right, or the exponential form. So if we had 2 cubed, we know that 2 cubed equals 8. This is an exponential form. I can convert that to the logarithmic form. If 2 is my base, I want my base here to be 2. So log base 2 if I refer over here, I had the base raised to the x power. So my power of 3 is the x, so I will be equaling 3 in my log. And b to the x equals y. In this case, y is 8, and y goes here. So log base 2 of 8 is equal to 3. If we were given a logarithmic expression, we want to convert back. Let's say that we have the log base, let me not do 2, let's do 3. Log base 3 of 9 equals 2. We can take this number at the end, and that will be the power on our base, and we'll say that it equals 9. And we know that 3 squared equals 9. So they mean the same thing, just a different way to write it. So let's practice converting back and forth. Actually, before we convert back and forth, sorry, keeping this all in one video. Let's talk about the inverse functions. If we just said that, and if we find inverses, one way to verify that functions are inverses is that we can check and see if f of g of x equals x, and check to see if g of f of x equals x. If we said that y equals b of x on our last page was the same thing as log base b of y equals x, to take the inverse of something, we'd switch the x and the y. So here you see that this would be the inverse because the x and y are switched. So these two boxes, green box and red box, are inverses of each other. Let's call this green one f of x, and the red one will be g of x. So f of x equals b to the x power, and g of x equals log base b of x. And we're going to evaluate or verify that they're inverses. So we're going to do f of g of x. If we take the function f, I'm replacing the x with something else. I'm replacing it with g of x. And the function g of x is log base b of x. When we have this base b, and it's raised to log of the same base, they can cancel out. They cancel out. The b and the log base b cancel out. We're just left with x. So here we've shown that f of g of x equals x. Let's also evaluate g of f of x. So g, I'm going to take the function g and I'm going to replace the x with something else. Oops. Should be writing b there. Log of b will equal x. But I want my function f of x to go in place of the x in g. So I'm trading those out for f of x. And f of x is equal to b raised to the x power. And here when we have a base of b and a log of the same base, log base b of b, those will cancel out as well. Log base b of b will cancel out, and all we're left with again is the x. So here we've shown that g of f of x will equal x. So knowing this could help us write exponential equations in logarithmic form and vice versa. What is the logarithmic form of each equation? Let's remember to use inverses. If we use inverses, we want to ask ourselves, what is the base? And then we're going to use the log of that base that we found. And this base is what we found in our exponential. So we can cancel some things out and rewrite this expression in log form. So in this first one, 100 equals 10 squared. Our base is 10. So we want to use a log base of 10. If I put a log base of 10 on both sides, whatever I do to one side, I have to do to the other. I'll see that I have a log of 10 and a base of 10. Those can cancel out. When they cancel out, I have log base 10 of 100 equals 2. So this is one way to do it. Another way is to know from the first page of our notes. We said b to the x equals y is the same as log base b of y equals x. Those are the same things. So if we had, in this problem it was 10 squared equals 100. If we know where to put those components, we can just transfer these around and know that the log base 10 of 100 will equal 2. So I just knew that my 2 was my x, so I had to put that at the end. I knew my 100 was the y, so I put the 100 here where the y was. So if you know how to transfer it around, you can certainly just do that. Instead of canceling out what I have highlighted, log base 10 and 10, I just think this is a nice way to keep everything straight. You know you're putting things in the right place. Less likely for errors. So 3 to the 4th we know is 81. We want to ask ourselves, what's the base? The base is 3, so let's take the log base 3 on both sides. Log base 3 of 3 to the 4th will equal log base 3 of 81. Well, this log base 3 and 3 will cancel, so 4 equals the log base 3 of 81. Now let's work the other way. If we have a log base 8 of 1 and that equals 0, I can take the base, oops, my board's a little off, take the base and use that as the base on each side. And then what we've started with, those are going to become our exponents. So 8 raised to the log base 8 of 1 will equal 8 raised to the 0 power. When I have 8 raised to the log base of 8, those cancel, so I'll just be left with 1 equals 8 to the 0 power. And that's true, 8 to the 0 power is 1. Anything raised to the 0 power is 1. Now if we know where things go, we can just put the 0 as our exponent for 8 on our base of 8, and it will equal 1. So here we can just transfer things around. 4 cubed will equal 64. So if you're confident you know where things go, you can do that. Otherwise, find your base, use that base on both sides, and what you started with will be your new exponents. So what I started with here, log base 4 of 64 is now my exponent on the side. And what I started with on the right is my exponent over here. 4 and the log base 4 will cancel out, so 64 will equal 4 cubed. And that's the same thing we had when we move things around. This is, again, a good way to make sure that we're confident we know what we're doing. The last learning target today is I can evaluate a logarithmic expression. When we use the word evaluate, we're asking you to find the value. Evaluate and find the value. What's the value of each log? So let's remember that b raised to the log base b of y equal b to the x. And log base b of y equals x is the same as b to the x equals y. So if we have log base 2 of 4, we want to evaluate this, so we're wondering, what does this equal? So we could call that x. If we know where to move things around, we're thinking 2 raised to what power equals 4? Well, I know that 2 squared will equal 4. So the question marks that I was looking for, I know it's a 2. So that's the value of this log. if you do it the way I just showed you on the previous page, log base 2 of 4, let's say it equals x. We're wondering those question marks, let's just call it an x. What does this equal? So take your base of 2 and write that as your base, and then log base 2 of 4 becomes your exponent. Put a base of 2 on the right, and your x becomes your exponent. When you do that, the 2 and the log base 2 cancel. I'm just left with 4 on the left. And we have 2 to the x on the other side. We convert 4 into 2 squared, so both sides have the same base. So 2 squared equals 2 to the x. Well, they have the same base, so take the exponents and set them equal to each other. So 2 equals x. 2 is the value of this log. So again, if you can do this quicker, thinking about it this way, 5 raised to what power equals 125? That's what we're asking when you ask you to evaluate a log. 5 raised to what power is 125? So if we take a 5, I'm going to set this equal to x. 5 is our base on each side, and I'm writing what I started with as my exponents on both sides. My 5 and my log base 5 will cancel, so I have 125 on the left and 5 to the x power on the right. Convert 125 into a base of 5. So 5 cubed will equal 5 to the x. I have the same bases, 5 and 5, so I can just take the exponents and set them equal to each other. So x will equal 3, or the value of my log will be 3. If you knew earlier that 5 cubed was 25, 125, you're in good shape. 125. So I have a few more for you to practice. If you want to try these on your own and move ahead, you're welcome to. It can get a little tricky though. 4 raised to what power is 32. So if I take a 4 on both sides, make the 4 my base, the 4s will cancel out. On the left, I'm left with 32. 32 equals 4 to the x. Well, I want these to have the same base. I cannot take a root of 32 and have a base of 4. So the smallest root I can have, I know that 2 to the 5th is 32, but I can change 4 to a base of 2. Let's call that 2 squared. So if I convert my 4 to 2 squared, I'm taking 2 squared and raising that to the x power. So I have the same base, but now my exponents, if I have a power raised to a power, I'm going to multiply those. So now my exponents are 5 and 2x. So take these exponents and set them equal to each other, since they're on the same base, and we can solve for x. Divide both sides by 2. 5 halves equals x. So 5 halves is the value of this log. Log base 4 of 32 equals 5 halves. Log base 27 of 1/3. What does that equal? We have a base of 27. Let this equal to x. So we have 27 to the x power on the right. 27 and log will cancel. 1/3 equals 27 to the x. Let's convert these so they have the same base. 1/3 I could also write as 3 to the negative 1 power. 1/3 is the same as 3 to the negative 1 power. I know 27 is 3 cubed. I'm going to take that and raise that to the x power. So I just changed the way I wrote 27. 27 is 3 cubed. So 3 to the negative 1 equals 3 to the 3x. So just take your exponents and set them equal to each other. Negative 1 equals 3x. Negative 1/3 equals x. The value of my log is this negative 1/3. Log base 1/2 of 8. Let's say it equals x. On both sides, I'm going to write the base of 1/2. So 1/2 to the x power. Over here we cancel. 8 equals 1/2 to the x. Convert these so they have the same base. I know 2 cubed is 8. I know 2 to the negative 1 power is the same as 1/2. So we raise that to the x power. 2 cubed equals 2 to the negative x. Take your exponents, set them equal to each other. 3 equals negative x. So divide both sides by -1, and -3 equals our x. So -3 is the value of this log. One more. Our base is 1/4. So 1/4 on each side. 1/4 of log of 1/4 cancel out. 16 equals 1/4 to the x. I know 4 squared is 16. I know 1/4 is the same as 4 to the -1 power. So 4 squared equals 4 to the negative x. And take those exponents, set them equal to each other. So -2 equals x. Finding the inverse. Last little part. To find the inverse of each function, we're going to switch the x and the y. So change places. X and y are going to trade up. When we're solving for the inverses, our first step is to switch x and y, which we just did. Our second step is to solve for y. And our third step is to cancel out the log, or simplify, cancel out log. And earlier we're switching x and y. I want to write down those steps, that could help you. If we solve for y, we need to get y by itself, so let's remove this log base of 3. To do that, I can take 3 as my base and put what I started with as my exponents. So 3 raised to the log base 3 of y. When I do that, my log base 3 and 3 cancel out, so I get the y by itself. So 3x equals y. Done. Step number 1, switch x and y. So x equals a log base of 1/3 of y. Get y by itself, so I want to use a base of 1/3 on both sides. Cancel out the log, and we have 1/3 of x equals y. So we found the inverse of those log functions. Take a second and write down a summary sentence about what you learned and try the 4 quick problems on the back.